DNS Part 1. In this nugget, we talk about DNS. This will be Part 1. We first of all will address why we need DNS and what it's used for. Now, you're probably already aware of many of those things, but I'll just make sure that we're on the same page. And then we'll take a look at the query process with DNS. What actually happens when someone types in, for example, a web address? Well, we'll take a look at that whole process. Then we'll take a look at creating and configuring the zones. Now, that's probably the bulk of what this whole nugget will be. So although it's one bullet, there's a lot of different things in there. You know, forward lookup zones, reverse lookup zones, stub zones, all the different options within the zone. Several different things to look at there. And then we'll take a look at zone transfers and replication. Now, first of all, why do we even need DNS? Well, one almost goes without saying, and that's, of course, the Internet. Almost any business that has any function at all in today's world needs the Internet. If not for web browsing, then at least for email messages, which most of the time will also traverse the Internet. And that's what gets us from A to B. Now, one other thing about that, regardless of whether it's on the Internet or in your own intranet, inside of your own corporation, is that you can't memorize a whole bunch of IP addresses. I mean, you can probably memorize a few, you know, your email servers, key file servers, a few IP addresses from different printers and routers and network equipment like that. But you just can't memorize all of it. And that's why we have DNS, so that we can access other servers by name instead, and in particular on the Internet. I mean, I don't know what www.cbtnuggets.com's website IP address is, but I do know www.cbtnuggets.com, so that's a lot easier for me to get to. And DNS will help to translate between that name and the actual IP address or the number for that host. And then you can also access other hosts, and anything that's on the network that has an IP address is known as a host. And you've seen my IP address a few times throughout the series, I'm sure, where I just do an IP config, and I think it's 10.10.10.70. See, even I don't memorize all the IP addresses, but I'm pretty sure the server we're looking at right now is 10.10.10.70. Okay, so it has an IP address, therefore it's a host. But there are other hosts as well that would also have IP addresses, like various network devices. This could be one of those devices that synchronizes time for you with an atomic clock out on the Internet, and then it has an IP address that your servers contact it by to be able to synchronize their time. So that would be one example of it. Other things would be routers. They all have IP addresses as well, usually multiple IP addresses for different paths and different networks that they're connected to. Printers also. A lot of corporations will use TCP/IP connected printers, and so that's going to be another type of network device. And then, of course, servers, file servers, mail servers, all that sort of thing. And then, of course, Active Directory. We have SRV records in particular in Active Directory that are useful for helping your client computers locate the nearest domain controller and therefore facilitate a logon for your user and for your computer both. And that's key. In fact, that's a big troubleshooting issue. If you are confident that you're entering in the correct username and password, but you still don't seem to be able to log on, or the security association has been broken between your workstation and the domain, then it's very likely, many times, that there's something wrong with DNS. It's not pointing you in the right direction so that you can find the proper domain controller. Now, before we do anything, it's probably going to be a good idea for me to just show you how an actual DNS query occurs. The first thing that happens is you'll have a DNS client, also known as a resolver, okay? And this DNS client or resolver wants to find another computer. Now, let's just say that it's this www.west.cbtnuggets.com computer down here, just a website. So what it's going to do first is it's going to look inside of its own client's cache to see if it has any information about that server. Now, how would that cache get populated? Well, if at some point in the past it was able to successfully resolve that through, a series of DNS servers or whatever, then it would remember that, and it would never have to access any of these DNS servers again for the time that the cache is active. And then it would just immediately go directly to www.west.cbtnuggets.com without really touching any DNS servers. But we got to populate that cache, first of all, through a query or through the hosts file. Now, we don't really use this very often anymore on clients like workstations, but a host file is simply a text file, and you'll locate this normally under your Windows directory, System32, the drivers folder, and then the etc folder. Here, I'll just show you because it's easier just to show. So let's go here, Windows, and I'm going to quickly go through this. System32. And then there's a drivers folder, and you can see the path up here. And then you'll see this etc item right here. And then here's the hosts file, which you can just open up in Notepad. And you can see this is what it looks like. Again, we don't use this very often on workstations anymore. You might use it on some servers that have to constantly have availability to some other server, for example. But this is similar to the kind of a format that you would use to enter it in. And these would be static entries that you manually configure. And then if you had multiple servers or clients that needed that host file, you'd have to copy it around to those other ones as well through some other means. But anyway, I might have a host record of this server. If I don't, then what happens is now I've got to start going into DNS and contacting my configured DNS server. Now, as I right-click here to choose Network and Sharing Center, I'm going to go here to Manage Network Connections, and then just to one of the properties of these network adapters. This is going to be the same for any version of Windows right now. And even if it's not a version of Windows and some other operating system, you'll use whatever their interface is to configure this. And here's where it's pointing to the preferred DNS server. So it's going to be 10.10.10.71 and or 10.10.10.70. Ooh, and I just realized something. This one's actually backwards. On DNS servers, normally you're going to point them to themselves first. So since this DNS server is also a domain controller, normally it's going to point to itself at 10.10.10.70, so I needed to change that. The reason why it was still able to resolve all this time was because .71 doesn't exist anymore. And if it's trying to access its first preferred DNS server and it's unable to access it, that's when it goes to the alternate DNS server. So probably my queries were taking a little bit longer than I would have expected. But the point I'm making there is that whatever's configured there for the preferred DNS server, that's the server that it contacts if it doesn't already have it cached or in the host file. And by the way, the host file is also loaded into the cache, so ultimately it's the cache before it goes to the DNS server. Now here's my nuggetlab.com server, and this is my DNS server. Normally domain controllers are also DNS servers in most instances these days. And the DNS server may not have to go out here to query any other DNS servers to be able to send a resource information back to this DNS client, because it may also have that information in its server cache. How would it get its server cache populated? Well, that would happen by if it has ever resolved this successfully before. For example, maybe just 3 minutes ago, another DNS client was looking for the same web server. This DNS server resolved it through a series of DNS servers. Now it still remembers that in the server cache, and there's something called a time to live, or a TTL. That record for that server is going to have a certain TTL, maybe an hour. That's about the default. And it'll stay in the server cache for an hour. After an hour, it'll say to itself, hey, that might be stale, might not be current anymore, so then it will do a new lookup the next time somebody wants to access it. So if it's got it in its server cache, it sends it back to the client. Otherwise, what it's going to do is to start performing a query. And I guess I better explain this cache DNS here too. This is where we will load our root hints for a DNS server. And this does also exist on the server, and let me just show you where that exists. Well, this will exist only on DNS servers, but you'll go into Windows, System 32, and then there's a DNS folder here. And that's where my cache DNS file is. And I'll just go ahead and quickly select Notepad here to open that up. And you can see here that that's where all the root hints, or rather the root name server hints file is. Now there's an easier and better way to do this than to work with this plain text file, but it can kind of be used as a failover or a backup method to populate root hints. But it's kind of falling out of need anymore in many cases, because the proper root hints are now updated through Windows Update Services. I'll talk more about root hints a little bit later on, but generally speaking, what that does is it allows you to traverse the hierarchy of DNS servers to ultimately to the DNS server that you need that will have a resource location, and you can just make note of this in the URL location of my web browser here to check out more information about the cache DNS file, as well as how to resolve it if it's corrupt or if your root hints are corrupt somehow. Okay, so just another thing to look at there. Now, what happens here is if it's not in the cache.dns, not in the server, it's not in the server cache, then the cache.dns or the root hints that's configured within the DNS server is going to go out to starting with the root server. So it goes out to the internet, and I'm thinking of internet queries here particularly, not necessarily intranet or corporate queries. We'll go out to the internet, and it looks for the root hints, and the first thing it goes to is the top level domain, which is really, it looks like I made a kind of a frowning face there, but anyway, it's really this dot here. the root of everything there really starts at dot. In fact, if you let me go back to a browser. If I type in www.cbtnuggets.com, that's all we have to enter into a browser. But in reality, what DNS sees is a dot at the end of it. Okay, and I could actually enter that in, and it would still work. See, if I just enter that in right now, it still gets me to cbtnuggets.com. But you see, this is what's actually going to be queried against first, is the root DNS server. Then, that root DNS server, get back to my diagram, will know about other extensions like .com, .gov, .org, whatever, .net, all of those things, including .com. So this server says, I don't really know this full address, but I do know where the .com servers are, and so then they'll pass the query on down to this .com. The .com server will say, well, I don't know where west.cbtnuggets.com is, but I do know where cbtnuggets.com is. So it passes the queries down this way. Then the cbtnuggets.com server says, well, I don't know about www.west.cbtnuggets.com, but I do know about west.cbtnuggets.com, passes the query down to here. And then finally, when the query arrives here, and this all takes place, by the way, on UDP port 53. So your firewalls do need to be open to UDP port 53 for queries. Then the west.cbtnuggets.com server says, hey, I happen to know who that is. That's at www.west.cbtnuggets.com, and their IP address is, whatever, 216.5.4.1 or whatever it is. And then it will pass that information back over here to this DNS server, which will then pass it back to the client. And then the client now knows how to access that particular server because it does so by IP address. Even though in plain English, so to speak, we still see words up in the URL, what's happened beneath the scenes here is that it's actually used an IP address to access this website. Alright, then having cleaned up here, let me talk about something else here as well. We have something called recursive queries and iterative queries. Generic DNS client, when it queries for a name against a configured DNS server, those are always going to be recursive queries. Recursive. Okay? So I got a recursive query to this server, which when I ask the question to the server, I say either give me the answer or tell me you can't find it. Okay? And that's pretty much what it's saying. Just give me an answer or tell me you can't find it. Don't tell me to go on a bug hunt to go all these other DNS servers. Just give me something. But the DNS server here, wow, it's under a lot of pressure. What if I don't have the answer? Now what am I going to do? Well, that's where it's going to iteratively query all these other servers. When it queries the root server, it gets a referral to this .com server and so forth. That is all, that whole process where it goes from one to the next over here is known as iteration. Okay, so it makes iterative queries to these other ones. So it would be iteration or iterative queries in this whole process here where it goes from one to the next. Another thing to keep in mind is that when it makes a query, any DNS query, DP port 53. So all these queries are taking place over UDP 53, and the reason why that's of some significance is that you'll need to make sure that there's no firewalls blocking that port. And if they're stateful firewalls, then of course they're going to allow initiated outbound traffic to go through there. But on the other hand, if you had maybe a firewall here between your server and the internet, and you had a www server down here somewhere in .nuggetlab.local, well, you would want people on the internet to be able to resolve against this DNS server to point to this www resource record for your server, for your web server. So in that case, you would need to open up inbound port UDP 53 explicitly, and the smarter thing to do there is to open it up so that it will only be able to contact certain IP addresses, create a rule for that. And then, of course, it would specifically contact only your DNS servers. And then the other thing to think about there is maybe I've got another server over here somewhere. Maybe this is another Nugget Lab DNS server. And it has the same zone as nuggetlab.local. So it's nuggetlab.local. Could be another domain controller, for example, or a secondary server. We'll talk about some of the more of those terms later on here in a moment. But we need to exchange information between these two DNS servers. They're ideally supposed to have the exact same information very, very quickly. We want to reach convergence quickly between those two. Now, what happens there is when data is transferred over here and is using a strict zone transfer method, then what's going to happen is it's going to use TCP 53. And And that's really the case only if it's going to be a secondary DNS server. And this would be a read-only copy of the zone file. If this was a DNS server that was also an Active Directory domain controller, then it would use other ports to transfer its normal Active Directory data, because the zones are actually contained in Active Directory on Active Directory DNS servers. Because they're normally Active Directory integrated zones. But we'll look at all of that again here in a little while. But in the meantime, just TCP53, zone transfers take place between like a primary and a secondary, for example, and UDP53 is what queries take place on. Alright, now here you can see that I've installed the DNS role on this particular server, which is a server that's just not a member of a domain or anything. It's just kind of sitting there waiting for something to do. So I decided to put DNS on it. It was really easy to do. You just go to roles, and then you just click Add Roles. And I didn't show you that because it's very simple, and you've seen me do that kind of thing many times before. You simply checkbox next to DNS, and then next, finish. And then what I want to do is to configure these zones. A DNS server has not much purpose unless it's got some zones configured on it. The only other thing it could be possibly is if it was some kind of a forwarder where it didn't have any zones at all, and that sometimes has a usefulness. But most of the time, you're going to see a zone on these. Now, the most common one we'll see is a forward lookup zone. At least that's where everything gets started. The forward lookup zone is going to be made by using a right click here and choosing New Zone, and then as you go through the wizard, you can choose primary, secondary, or stub zone. Now, let me explain a little bit about this. A primary zone is a read-write copy of the zone, and that means that if this DNS server answers the question about a query in this zone, it's an authoritative answer. Okay. Now, a secondary zone can also answer authoritatively, but I'll talk about that more in just a little bit. The thing that we want to do with the primary zone is to go ahead and create it as the read-write copy. If we do this in a conventional sense, then there will only be one copy of the primary zone. There cannot be two or more copies of the primary zone. If I want to give myself better load balancing or failover capability, then I'll have to create other DNS servers elsewhere that are network connected, and I'll make them secondary zones. A secondary, what it does is it draws a copy down from the primary zone, and this copy goes only one direction. It goes from the primary to the secondary, and this is then a read-only copy of the zone. And I could do that on, again, some other server to pull down that information. And then here with this stub zone, what I'll do is I'll say to myself, you know what? I have my users that are constantly accessing web servers and printers and file resources on a business partner of ours that I don't manage. For example, maybe there's AccuSource.local. Well, I work for NuggetLab.com. I never touch the AccuSource.local DNS servers. They're not my responsibility. I don't know what's in their zones or anything, but I know we do business with them a lot. So I'll create a stub zone on my DNS server, and what will this stub zone contain? It only contains enough information to send my clients over to their DNS servers. So it kind of dishes off the responsibility entirely. It says, don't ask me, ask these guys, whoever's listed in my stub zone for AccuSource.local. And it'll have a name server record, a start of authority, and possibly a glue or a host record. And we'll talk about some more about those when I actually configure this. But this is going to be a server containing a stub zone. As you can see there, is not authoritative for that zone. It's not going to directly answer any questions, but it's going to point you to a server that can answer the question. And then we have the primary zone here. I'm going to configure now, and I'll configure these other two here shortly as well. But the primary one, I'll just enter in some name, and let me just enter in here, for example, NuggetLab.local. Now you know that I've already got NuggetLab.com over here on my other server that I've been working on for our whole series here. Here I've got NuggetLab.local. How might this be useful to divide that name up there? Well, there's something called split brain DNS that there's a number of different ways of implementing, but one of the concerns that we will often have for security purposes is that I don't necessarily want my users to be in NuggetLab.com on my internal network and to have my web servers and all my public servers also on NuggetLab.com. That does present some security concerns. There's a number of elaborate ways to get around that, but another thing that you could do is to just have all your users internally on NuggetLab.local. And then when they log on and they get the drop-down list for domains, it's just going to give them the flat namespace anyway, so they might not even know that they're in NuggetLab.local. And if they log on with a user principal name, then of course you can add an additional UPN suffix for those users so that they can log on as nuggetlab.com, but it's actually going to be logging them on into the nuggetlab.local domain. And I've shown you all this elsewhere in our series, how to create a UPN suffix, but just as a quick refresher, going back to Active Directory Domains and Trusts, and I would go up here, right-click directly on the top, go to Properties, and add an additional UPN suffix for, nuggetlab.com, for example, and then click Add, and I'm already in nuggetlab.com, and I'm just showing you where you would enter this information in. And then once I clicked on Add and OK, then my users would be able to use nuggetlab.com for their UPN logon, but it would actually be taking place in the nuggetlab.local domain. Okay, so now let's move along. That's the name of my zone. Now I want to create a new file with this name. Notice that early on in this, there was a checkbox that was kind of grayed out, but it asked me if I wanted to store this in a Active Directory integrated zone. Well, this is just a standalone server, so it's not a domain controller. And as such, it cannot store anything in Active Directory because it doesn't have Active Directory. So it all has to go into a file in this case, and that's what we'll do. I'll just go ahead and store it there. If I had an existing file, maybe the case of, I copied the file from another DNS server, then I could use an existing file. We don't do that very often unless we're in very, very large implementations, which have hundreds or even thousands of records in their zone file. And then it'll be faster and more efficient to just read from an existing file instead. Otherwise, when I configure this, especially if it's a secondary, then I'm going to have to read from another server to pull it down. Okay, then we go ahead and here click Next. And then this page here is going to have some important things relating to probably relating to your exam, honestly. Notice that this again is grayed out because I'm not in Active Directory here, but if I were, this would be the best one to select. Allow only secure dynamic updates recommended for Active Directory. Now this is going to verify that anybody who registers a host record with me, and that can be done automatically with DNS enabled, or rather DHCP enabled clients when they release their IP address from the DHCP server, they can also self-register their own host records in DNS. And then when that happens, that would be what we're talking about here, where they can register their own secure dynamic updates. Okay, but when we choose that top option, that means that they have to be authenticated as a genuine host in my accusource.local or my nuggetlab.local or whatever zone. Okay. Then we choose to allow both non-secure and secure dynamic updates. This is the case if you have to do it. You don't really want to do that option most of the time unless it's for backwards compatibility with really old clients, or you have maybe non-Windows clients that have to register themselves. Or you can say do not allow dynamic updates. And this would be the case if you just didn't have any choice and you were doing everything manually. I'm going to leave it at the bottom one because since I'm not part of Active Directory anyway, it doesn't really much matter. So then I'll click on Next here and click on Finish. And that's pretty much it. Now you can see here that I do have now my nuggetlab.local zone. And I'm going to collapse this a little bit so we can see a little bit more information. Now then let me talk to you about what we have here in the zone. This is nuggetlab.local with two items in here. One of these is the start of authority, and the other one's the name server. Simply identifies the name of the server. So that one's pretty well self-explanatory, but start of authority has a few other things in it. First of all, notice that it has a serial number. Remember, we can have primary and secondary servers. How do the secondary servers know that there's new information to pull from the primary? Well, when the serial number increments, it only increments on the primary. Secondaries don't ever increment because they're only read copies, right? So here on a primary, I can make changes, and when I do, it'll increment this number, or I can manually increment it if I want to give it a kick in the pants. Let's give it a practical example here. I'll add a host record, which should increment that number. And then I'll just call this, server1.nuggetlab.local, and the IP address of, and I'm just making this up kind of arbitrarily for the time being, but I'll add a host record just so that it has something to do for the time being. Now, once I've added that in, now when I go up here to the parent folder, look, it tells you right there that it's still serial number 1. Well, what's that about? Well, if I hit F5 on the keyboard, you'll see that it does refresh. You will find that sometimes you'll think your mind's playing tricks with you with DNS and in the console here, because there are a lot of times you'll make a configuration change and nothing happens. But now when I double-click on this, of course, again, now that I see that it's number 2, and if I want to increment it again, I can do so with that button over to the right. Then this is the primary server, which is identified here. If this was a member of a domain on its own, it would give me the full name there. So it would be nugget2 dot whatever, nuggetlab.com or something like that. But since it's a standalone server and it doesn't register itself, then that's where it stops. Then there's the responsible person. This normally also would have a domain at the end if it was something like an Active Directory integrated zone. But in this case, it's again where I'm on a standalone server, it didn't fill that in for me. But if I was, it would be something like, oh, who knows, I guess I'll use the zone RIN, nuggetlab.local. Okay? And the same with the primary server that may also appear there as I just mentioned, just so I can fill it in here just for clarity's sake. Okay? So you may see that on servers that are members of that same domain. It may automatically fill in. The responsible person, by the way, it always says hostmaster. You can put in a legitimate name of somebody if you want, but just keep in mind that whoever you put in there is going to get hassled by the internet public if somebody wants to know anything about this zone, and who's in charge and what your TTL is and anything else like that. So what I would normally do is I always used to put my boss's name right there. By the way, this is also an email address. You might say, James, that's the strangest email address I ever saw. Where's the little @ sign? Well, these fields can't take an @ sign. It's not capable of putting that in. So even though it says dot here, it's kind of implied that that's actually an @. So this would be hostmaster@nuggetlab.local. Okay? And of course, you can browse for other accounts if they're available as well. Then we have something called a refresh and retry interval. What's that about? Well, you see, when a secondary wants to pull records from the primary, it will refresh every 15 minutes to see if there's any changes. However, if it's not able to contact the primary, it will retry after 10 minutes. If it keeps trying and it's still unable to get anything after a day, then it will give up and it will just give you a red X on the console for that DNS server, and you'll have to kind of go in and rejigger it and fix it. So that's technical jargon, rejigger. So you'll have to go in and resolve whatever problem is preventing you from being able to transfer the zone from your primary to your secondary. And then there's the default TLL here, and then there's also a TLL for this record, TTL that is. Well, that seems kind of redundant. Why would I have it in both places? Well, this minimum default TTL is for any other host records that I create. For example, this server 1 host record I just created, it's got a TTL or a time to live of 1 hour because of what was set here. If I were to set this for a different interval, seconds, 5 seconds, then the TTL would be only 5 seconds long. But that would cause probably a lot of unnecessary additional queries that could have been answered out of cache, but would have expired if I had made that too short. On the other hand, I could make this too long, and I could make it, 30 days or something like that. I don't know, 5 days. And it could be that whatever it's pointing to will have been updated by then. It might be a laptop user that comes on and off the network. Every time they come on, they get a different IP address, for example. Well, it could be that would then become stale. So you don't normally want to make that too terribly long. An hour is usually a good idea. And by the way, going back to that laptop example, if they're registering with DHCP anyway and getting their IP address that way, then they will automatically re-register their own records. So that's not quite as much of an issue for that as it would be for a static record that had changed. Then we have a TTL for this record, and that is for this exact SOA record that we're looking at right here, but not necessarily for anything new that we create. Those two could be different. Okay, so that gives us a good start on the start of authority. Now, while I'm at it, I think I'm just going to go ahead and cover our other tabs here. Let's go back to the General tab. This is what would have occurred if I had simply right-clicked on nuggetlab.local and chosen Properties. And here I can specify whether it's running or not. I can pause this if I want to. Why would I want to do that? Well, troubleshooting, or if you want to just put the whole zone on pause for a moment while you checked into an issue. Also, I could change it from a primary to something else. I could change it to a secondary. If I do a secondary, then I have to point it to, however, wherever the primary actually is so that it can make sure that its records keep updated. I can also change it to be Active Directory integrated, and I have a few choices there, which I'll show you later. Notice that, again, is grayed out because I'm just using kind of a very plain text-based zone file type of a server here that's not Active Directory. And then I have the zone file name. That's the text-based part of it I was telling you about. Any records that I create will be stored in nuggetlab.local.dns in the DNS folder that I showed you a little bit earlier. Then you can specify dynamic updates. I can say, no dynamic updates or non-secure and secure. I would otherwise also have secure only, but since again I'm not part of Active Directory, it does not give me the ability for secure only. What would really happen here is it would be none and non-secure. These are really both the same thing because it can never accept secure, so the whole second half of this one really is kind of a non-issue. Then we have aging and scavenging properties. What's that about? Well, you click on the aging button there, and you can see what happens. You see, I might have, once again, a server with stale resource record data in my DNS server. It might be, somebody who visited my company 6 months ago, and they registered with my DHCP server, they registered a host record, and then they left, and they will never come back again. Well, they still have a host record in my zone. What I could do there is to scavenge anything that's older than 7 days. But that's actually going to be located down here. This is a little bit of a confusing interface, so let me try to clarify what's going on here, because it looks like it's just two items that are saying the exact same thing, right? Well, here's what could happen. If I have, for example, my normal desktop users, they come in, they start up their computer in the morning. Well, it gets a DHCP address, it registers its address, it registers its host record with the DNS server. Okay. Then tomorrow they come back in and they do it again. And maybe they had some problems with their Windows Vista machines, so they had to reboot 3 or 4 times during the day. Well, every time they do that, it re-registers their host record, which then also increments the start of authority record, and it will then needlessly start to duplicate those host records that they've refreshed over and over and over again. And it will start to draw those down to the secondaries unnecessarily. It's really the same data. I just rebooted, that's all I did, and yet it still updates it. So if I choose a no refresh interval, that means that once I get my host record registered, it will not be able to refresh for 7 days. And that helps to make sure that we don't get redundant and unnecessary refresh. And then we have this one right here. This is where it actually says that in 7 days, it's going to go ahead and refresh it. Okay. So that's what that's about. If I leave that checked, then it will scour for anything that's older than 7 days, and it will get rid of it, delete it from the zone. Now let's go ahead and talk now about setting up a secondary for this server. And if I did that, I would need to allow zone transfers. Right now it says allow zone transfers only to the servers listed on the Name Servers tab. And if I go over here, there is none, except for this existing server that we're looking at right now. So there's no additional named servers there. So what I would need to do is to go to those other named servers, or those servers I want to be secondaries, create a secondary zone over there, pull the data, and then they should show up in the Name Servers tab, and then it would only send data to those, do zone transfers to those. I can also say allow zone transfers to any server, which is not a good practice in terms of security. Can't think of any real good reasons to use that one other than just in a lab, and you can't seem to get any zone transfer to work for any reason. And if you're in a closed network, you might try it just for testing purposes. The other thing you could do would be only to the following server, and then you would edit the list, and you would just add in the IP addresses of any servers that you wanted to transfer the zone over to. I'm going to leave it with the default setting there, however, and in a moment we will go ahead and configure that. In brief, though, I do want to point out the Wins tab. We don't really have a lot of emphasis for Wins right now in this particular exam, but if it's not able to resolve something like, nugget1.nuggetlab.com or something like that in a fully qualified domain name, and you do something like a query against a flat namespace, then it may need to use wins instead. And here you would choose to use wins forward lookup. And what that would do then is it would allow you to use a wins server to resolve flat namespaces. But what I want to do now is go back here to our zone transfers tab to point out that right now there's nothing there. And there's nothing on the Name Servers tab except for the one that's already there. And now I'm going to go ahead and go to a different server, and I'm going to go ahead and, I think I've already got it open here. In fact, there we go. And then we're going to go ahead and create a secondary. Okay, so here I am on Nugget 3. This finally came up, and I'm going to create a forward lookup zone. This is just a newly installed DNS server with no zones whatsoever quite yet. And as I step my way through the wizard to choose a secondary zone, then I'm going to click on Next and identify the name of the zone, which is nuggetlab.local. And then it asks me for the name of another server to copy from. Now, in this case, they only have the primary as the only other DNS server for this zone, so that's what I'm going to have to put in. In a larger organization, I might have one primary, and you always have only one, unless it's Active Directory integrated. And then I might have multiple secondaries. I might even have dozens of secondaries. And I can add all of those here into the list. And what it will do is it will try to pull from the first one on the list. If it can't contact that one in a timely fashion, it'll go down to the second one, go down to the third one, and so forth. I'm going to enter in the IP address. I think it's at 10.10.10.72. I hope it is. There it is. So that's nugget 2, all right? And we have now validated that one. And then I click on next, and then I click on finish. Now, if I try to transfer the zone right now, it's going to give me a problem. And the reason why is because, remember, I don't have that fully configured yet over on nugget 2. I'm going to have to go back into these properties and do a couple of different things. I'm going to go to the name servers, and I need to add in this name server here. So that would be DC nugget, no, rather it's just nugget 3. And there it is, nugget 3 is right there. By the way, you might have seen this off to the red X and this over to the side. All that's telling me is it's not authoritative for the zone. Okay, that's okay for the time being. I just want to put it in there. And then the zone transfers only to the servers listed on the name servers tab. Nugget 3 is one of them, so that should be fine. And I'll just click apply for the time being and go over to nugget 3 again. And then what we'll do is we'll just transfer this. Oh, it's already transferred. Okay, just about as soon as I did it, there it is. Notice that, now let me clear up the space here a little bit. Notice that it also automatically added in nugget 3. You might have detected that I looked a little bit surprised, or I sounded a little bit surprised when I saw this here, because a lot of times this will take a few moments to come up. Sometimes it can take several minutes, and you might have a big red X here, and it doesn't look like anything's happening. You might have to go here and transfer from the master or reload from the master, something like that. It tells me right now, for example, transfer in progress. So it will do those things for a while sometimes, and it'll look like something's going wrong, but you're usually fine if you're just patient with it and refresh things and so forth. Alright, now here I am back on nugget 2, and we have our forward lookup zone. Remember, this is the primary for nuggetlab.local, but I also want to go here to the reverse lookup zones. Now we have a few different types of zones left that we still need to cover. The reverse ones are useful if I want to do just that, reverse the normal name query. Because normally I want to resolve a query against an IP address. So I'll look for www.nuggetlab.com, and I want to get back an IP address, 215.16.17.1 or whatever it is. In this case, however, I might not know the name of the server or the host, but I do know its IP address. So let's say that I'm getting a huge flurry of broadcast packets on the network. This can happen sometimes if a network card starts to fail, but it's causing me a lot of network chatter. Of course, it could just be a Windows machine because they're notoriously chatty anyway, historically speaking. So what I could do is say, I'm getting a lot of chatter from 10.10.10.5, but I have no idea which computer that is. I don't know if it's a user's workstation. I don't know if it's in the server room, wherever it is. So I'll look it up. So I'll create a reverse lookup zone, create a new zone, and this initially is created the same way, primary, secondary, or stub. We're creating a primary one. That's normally how you might do this. And then we'll click on next to specify IP version 4 or 6. Both are supported, but I'll stick with version 4 for now. And then you simply enter in the network ID. Now here it's just going to be easy because it's 10.10.10. But if you have different octets in each one of those, it might be 192.168.5 or 6, something like that. Okay. In this case, I'm going to use 10. Because that's my network. Okay, and it'll look something like that. And this is normally what we're going to use. We could also type it in, but I say, why? I just rather enter in the numbers here, and it'll do all the rest of it for me. I guess it cleared it all out there, didn't it? Okay, so then we'll click on Next, and then we'll create a new file with this name, or we'll use an existing file similar to what we had with the forward lookup zone. Really no difference there. And we could allow or not allow dynamic updates. And again, it's not integrated into Active Directory, so I can't choose Secure Dynamic Updates. And then Next and Finish, that's pretty much it. Now then, you can configure the settings here for the client side, but I'm also going to just do it manually so you can see something appear down here. I could right-click here and choose to create a new pointer record. That's the kind of a record you create normally in a reverse lookup zone, although I could do a CNAME as well. I normally will only do a pointer record, but here I could also do it manually from this side. So I'll right-click here and choose a new host record, and that's what you'll do on the forward lookup zone. On the reverse lookup zone, I want it to create a pointer record for me automatically. And let me show you how I would do that. So let me say it's a server 5.nuggetlab.local, and its IP address, maybe it's 10.10.10.34, something like that. Then what I could do is to create an associated pointer record. Now when I click on Add Host, It successfully creates this, and when I'm done, we'll go back into the reverse lookup zone, and as I refresh the screen, we see that now there it is indeed. So to reiterate, what this will do for me is this. Let's say I get some unusual activity or something from 10.10.10.34, but I don't know who it is. I'll just do something like let me show you. I'll do a start command prompt, and I'll do something like a ping minus A. A ping minus A will do a reverse lookup for me. And I say I'm looking for 10.10.10.34. I have no idea who they are, but they're causing me problems. I need to chase them down and beat them up with a baseball bat. Okay, so I'll press enter here, and then it tells me, oh, it's that system, actually. See, it resolved it to that, and that happens to be my laptop computer. All right, so let's see how this is going to go ahead and work. Now, I could, again, right-click here and choose a new pointer record, and pointer records are what we use in reverse lookup zones, but instead I'm going to go up here to do what would more likely occur, and that would to create a new host record, and then I'm going to have it automatically create the pointer record for me. So maybe the host record I'm looking for is Lenovo 64. That's my laptop over there to my left. 6.01, okay? And then its IP address is, hopefully I'm remembering that right. Then I'll add that host in, and it was successfully done. Okay. Now, since I had this checkbox for the pointer record, we see here that when I created this, it automatically created, if I refresh the screen, there it is, automatically created this pointer record for 10.10.10.34. So, what I should see is, if I try to resolve 10.10.10.34, it should point me to Lenovo 64-01. So I'll do let's try this. Let's do a ping minus A. That does a reverse lookup. 10.10.10.34, and it resolves it indeed to Lenovo 64. Okay, so that's exactly what I wanted to happen, and now I'm able to identify which system it is that belongs to that IP address. Now then, let me go ahead and back over here to my main server that you've seen me work with most of the time. This is my domain controller. And then let's talk again here about the Active Directory integrated zones by right-clicking and choosing New Zone and clicking Next. Here I can create a primary zone as well, and I'll store the zone in Active Directory if I want to this time. And I get that checkbox because this is a domain controller, and therefore it can store the zone data in Active Directory. Then I can specify how I want the zone data to be replicated. And this is going to go way beyond just our standard primary and secondary kind of a replication cycle. Here we're going to use normal Active Directory replication traffic to store and replicate all the DNS data. It's much more efficient, reliable, and dependable. So, all those good words. So what I can do is to also specify, do I want this zone? Let's say I'm going to create a new zone for a website. Can't think of one right offhand. Oh, I know. I've got a zone that I registered, so I'll just use that one. So I'm going to register to something called hisearthmyworld.com. You'll see that in a moment. So what I want to do though is I want that to be stored for all DNS servers in this domain of nuggetlab.com. So if I've got 5 DNS servers in the nuggetlab.com domain that are Active Directory integrated, it will send it to all 5 of them. If I have a larger infrastructure with maybe several trees and so on throughout the forest, I could send it to all DNS servers in the forest, and then all DNS servers in the forest would be able to resolve authoritatively that name. By the way, anything that's Active Directory integrated that has that zone is going to be an authoritative DNS server for that zone. Down here, I could choose to all domain controllers in this domain for Windows 2000 compatibility. That's because Windows 2000 compatibility did not store the DNS records in a partition. Technically, this is all going to be stored in an Active Directory partition for the DNS zone. 2000 did not do that, so it has to use other means, and that's why that last option is available. Oh, I forgot the last thing there. Sorry. There's also this one: to all domain controllers specified in this scope of this directory partition. I could create a directory partition, and then that will appear down here. Creating a directory partition is all done from the command line, and you have to use a DNSCMD to be able to create it, and then it will give me a zone that I can create from here, or a directory partition that I can create from there. And then I'll enter in the name of the zone, and it's just hisearthmyworld.com, and the reason why I made it camel case was because it's kind of hard to read otherwise. So hisearthmyworld.com. And now notice that I do have the ability to allow secure dynamic updates, so that once again, when my clients receive a DHCP allocated IP address, then they can automatically register themselves in Active Directory. And this is the best option there to do that first option, because it's also going to be secured updates. That would prevent, for example, a hacker from plugging their laptop into my network and just populating it with false records. That's pretty much all there is to it. Now I have an Active Directory integrated zone for His Earth, My World. And to reiterate, the Active Directory integrated zones are automatically created for Active Directory, and that's their primary usage. But you can, of course, put any other zones in them that you want your DNS servers to resolve. Again, the advantage with that as well is that will then automatically replicate to all other domain controllers in the same domain or the entire forest, and I don't have to manually configure a bunch of secondaries the way I would have to do with this traditional primary-secondary infrastructure. Now, we also have conditional forwarders. You see, let's say I don't manage AccuSource.local. That's another company that we can contact or that we can work with. But I need my clients to be able to figure out a way to resolve to AccuSource.local. Or actually, I need to figure it out for them, not like my users are going to figure this thing out. So what I need to do is to right-click here to choose a new conditional forwarder. And what I would enter in is the domain that I'm looking for. And what this will do is it will point my users to the DNS servers for AccuSource.local. So here it is, AccuSource.local. And that's the name of the domain. And then here I'm going to add the IP address for AccuSource.local. I happen to know that DNS server is 10.10.10.5. Oops, I guess I didn't enter in the whole thing, or I backspaced over it or something like that. So let's go ahead and enter in a 5 here. And then it resolves it. It's trying to resolve it. And it's validated as okay, so it's been able to properly contact it. And then I can store this conditional forward in Active Directory, and again, store it for all DNS servers in this forest, or only DNS servers in this domain. It just depends upon what your needs are. That, again, would be very handy because now I don't have to manually go around to all my other DNS servers and put this in, by hand. I just by doing this, which could take, 30 seconds, I could have done this for dozens of domain controllers or DNS servers automatically now. And then it will give me a number of seconds before the forward queries time out. So if for some reason this DNS server is down, then it will just time out after 5 seconds and not kind of just leave my queries out there in limbo. So now I'm going to go ahead and click OK here. And then what I want to also do is to go to a command prompt, and I'm going to right-click and choose Run as Administrator, because this does need to be done from an administrative command prompt. And I want to make sure that I clear any previous queries that I've resolved. I can't quite remember everything I've resolved here, so I want to do an IP config and then flush DNS. Okay, and that means that anytime I've been able to resolve a name in the past and it's stored it in my cache, like I showed you in the diagram early in this video, in this particular nugget, I want to clear that out. Okay, so I'll clear that cache right now. And then also, I want to do another thing here. Actually, I want to do it this way. I want to run DNSCMD clear cache. Now, why am I doing that? Well, that's because, remember, the DNS server is also here, and it has also already resolved some names for me on the network. Well, I want to clear anything that it has cached as well to give myself fresh information. I guess I better type this correctly. DNSCMD. There we go. And once I've done that, then I want to go ahead and just test this out, see if I can resolve something over there in nuggetlab.com. So let me do a ping, DC, well, I think it's just DC1. And it's able to resolve that. But I can also do this, and notice that it just returned the flat namespace. That's because this local computer in its TCP/IP properties does not have configured AccuSource.local as a domain suffix. But I can go ahead and do it this way. I can go ping dc1.accusource.local. And this time we will get, indeed, fully qualified name resolved. So now the fact that I put in this conditional forward, it means that I can resolve anything that's in the zone for AccuSource.local. Now, I alluded to something a moment ago that I just think I need to clarify because I don't want to leave you hanging out there, but I mentioned something about the DNS suffix. Let me go to our network properties here to explain just briefly about that because it's a little bit off topic. But I'll manage the network connections and go into the properties of a network card, and you've seen me do this many times. And then I'll go back into TCP/IP version 4 here. And then now when I go to advanced, there's a DNS tab here. This is where I can append DNS suffixes. Right now it's going to append the parent suffix of the primary DNS suffix automatically for me. So since this server is a member of nuggetlab.com, it's going to automatically do that. So if I were to ping DC1, then it's going to try to see if there is such a thing as DC1.nuggetlab.com. Since there wasn't, it just returned a flat namespace for me, and that was it. but I could have also appended these DNS suffixes in order, and if there's a set of regular suffixes that I also refer to, I could add them in here, nuggetlab.local, accusource.local, whoever I need to do. That is another possibility that I can enter in there to resolve names a little bit more accurately for myself. Alright, now as cool as this is, there's also a slight disadvantage. See, I've only got one DNS server that I've listed over there, and if they have any more DNS servers, they have to send me the memo or the email or text me or something, and I'll have to find out what those other IP addresses are and manually enter them in here. That's where you get stub zones that can be a real advantage for you. So I could create a stub zone which is going to handle that quite a lot differently. Let's take a look at how that could work. Here I've got a command prompt. And try to think of a domain that we would all know. How about Google? Okay, so let's do a NS lookup. And you don't need to memorize the stuff I'm showing you here unless you want to. It's just kind of a way that I can find out what their name servers are. But NS lookup, and then I'm going to do a set type equals NS. I'm looking for their name servers. Then I'll just type in google.com. And voila, there's all their name servers. Okay, let's do another one just for fun. How about yahoo.com? Wow, it looks like Yahoo has even more than Google, right? 1, 2, 3, 4. Yeah, they have one more, so I guess Yahoo must be better. No, just kidding. So I like Google. So let's go ahead and use one of these addresses. Let's take that one. I think they're all different. Yeah, they're all different. And now I'm going to go over here and create a stub zone. And watch what happens when I create this. And this is all pretty straightforward, and you've seen me do this many times. So I'm going to kind of quickly go through all of this stuff. But I'm looking at google.com, and then I'll enter in the IP address and press enter. It's going to try to resolve it. Looks like it did okay. And that's pretty much it. Then when I click on next and finish, watch what happens with this Google zone. Wow, it automatically populates it with all the rest of them. How cool is that? Now if they add an NS5 and an NS6 and so forth, maybe try to catch up with Yahoo, well then they'll have these populated automatically. So this is really pretty cool, this whole idea of stub zones. And no, it's not Microsoft's invention. Other DNS implementations have used it for a long time, probably since just about the history of the internet practically. But Microsoft caught on to this, and they started actually using this in Windows Server 2003. Alright, this nugget's getting kind of long, so I'm going to go ahead and conclude here and talk about some other DNS stuff in the next nugget. Before we conclude here, though, I want to wrap up some things to make sure that we're clear on a few things. Number one, if you have an Active Directory integrated zone, then if you make them Active Directory integrated, you have a much more reliable and secure method for transferring and replicating your zone transfers around. Among other things, your Active Directory data, including your zone transfer information, is all encrypted, in addition to the fact that it's secured in other methods when it sends the zone transfer data and other Active Directory data to other domain controllers. And although you can reasonably secure primary-secondary zone transfers, it's not as good as what Active Directory can offer you in terms of security. Also, the primary-secondary is not as timely because there might be some time that goes by where you've made some changes, but and it hasn't yet replicated those changes to your secondaries. However, with Active Directory integration, you have things such as the Intersite Topology Generator and the IS and other things like that to make sure that you have a good topology and a good replication cycles between all your domain controllers. So they're going to get likely to get DNS updates in a much more timely and accurate fashion, especially in a global organization with multiple sites. So in other words, your best accuracy is going to be with Active Directory integrated. Really, there's not a whole lot of reasons for primary-secondary if you can avoid it. One other thing is, remember we do have a new kind of domain controller with Windows Server 2008, and that is the read-only domain controller. If a read-only domain controller is also a DNS server and it has Active Directory integrated zones, that is the one exception to where that Active Directory integrated zone is not both read and write. Because it's a read-only domain controller, it's also a read-only copy of that zone. So it's primary, but it is also read-only, and that's kind of a, I guess a contradiction according to our traditional thinking with that, but that will be the case with the read-only domain controller. Another thing you should be aware of with secondaries is that you might have bind servers, which is the Berkeley Internet naming daemon servers. It's a Unix-based type of a server that a lot of people have been using for years and years, and which has been very faithful, tried and true for DNS servers. So if you have somebody in your organization that still wants to stick with bind, but you need to make them secondaries, you can go to the name of the server here in Microsoft land, go to Properties, and then go to the Advanced button to select Bind Secondaries. And I'll talk about some of these other things here in a little while in our next nugget. But that's one thing in particular that I want to point out just for now, that if you have secondaries that are bind servers, make sure that checkbox is selected, because it has to format the data in a certain way to make it compatible with bind servers. Now, briefly, let me also talk about the various kinds of records that you can create. We already saw the start of authority and name server, which are created automatically with the zone. Host records we've seen quite a few of. Here's a CNAME record, which we created in a previous nugget, which I've already explained, but just by way of review, remember that's where if people go into one location like rms.nuggetlab.com, I want them to actually be redirected to nugget2.nuggetlab.com. That's the name of the physical server that they access. They think it's this server. In reality, it's this server here, and we'll very often use that as well for something like www. So if someone goes to www.nuggetlab.com, actually it's already filling in, someone goes here, I really want them to go to webserverfarm.nuggetlab.com. Okay, so I might do something like that instead. And then what would web server farm be? Well, that might actually be a number of actual different physical servers. So how would I actually allow them to go to a specific server? By creating a new host record and typing in web server farm, okay, .nuggetlab.com at 10.10.10.90, if I can type, okay, and then I'll click add host. Okay, it was successfully created. Let me do that again though. Web server farm.nuggetlab.com. How about 10.10.10.91? And then I'll add that host. Now, what have I just done here? Let me close this up. I'm using a round-robin method. This means that when someone tries to resolve www.nuggetlab.com, it actually takes them to webserverfarm.nuggetlab.com. What is that? Well, it's this host, but it's also this host. What will happen is these will take turns, and I can have dozens or hundreds of these. It'll take turns alternating between each one of these in sequence, and thereby perform kind of a rudimentary load balancing for me, distributing the load between all of those web servers. And that's a very common method for configuring a web server farm. Same kind of thing can be done for mail servers, by the way. And that takes me to my last kind of resource record that we want to address right here, and that would be a new mail exchange record. And here we would have to enter in also the name of the the server. Mail would be what people would look for. But when in reality, it might actually come into mail server, exchange, something, I don't know, .nuggetlab.com. And then you can enter in a mail server priority, lower numbers being higher priority, and that's pretty much that. Then you just click OK and the record's created. In this nugget, we talked about DNS, and this was part 1, where we started off with a discussion of why we even need DNS. Remember, it's what's going to resolve our internet names and make Active Directory work, and in the corporation, that Active Directory component is critically dependent on proper configuration of DNS. And then we also took a look at the query process. What happens when a resolver tries to find a website, for example? Is it a recursive query, an iterative query, what ports need to be open, and so forth. And then we also took a look at how to create and configure zones, which is probably the bulk of this particular nugget, because there's a lot of different kinds of configuration, different kinds of zones, and different kinds of records you can create within those zones. And then we took a look at zone transfers and replication. Remember, zone transfers are what you have with primaries and secondaries. With replication, that's what's going to happen with Active Directory integrated zones. Well, in our next nugget, we'll take a look at some other things relating to DNS, but in the meantime, I hope this has been informative for you, and I'd like to thank you for viewing.